Good day, grade 12 learners. Welcome to today's mathematics lesson. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. My name is Annelen Sindane, and today we are going to look at paper 1 revision, and we'll be focusing on functions. Now, we are aware that functions in our paper 1, the total mark is 150 for paper 1, but functions contribute 35 marks. And we are aware that functions are related to algebra as well as calculus. But you will find out that we use lots of functions in the different topics that we are going to be doing. So we need to understand functions, and we are going to be focusing a lot on the approach on how we can easily solve problems that involve functions. Now, we know the weighting per topic for our paper 1, but I have highlighted functions because this is the topic that we are focusing on today. And we know that it's 35 plus minus 3. It can be a minimum 32 marks or a maximum of 38 marks. Now, the minimum target that you can get for you to pass functions, you must get at least 15 marks. And for you to get a bachelor pass, you must get at least 20 marks under functions. And it's easy for you to get all the marks in functions if you do the basic mathematical needs of the topic that we are going to look at today. Now, we need to understand and sketch functions, focusing mainly on the understanding of the basic function. We should look at our intercepts with the axis. How do we get our intercepts? And we know that for us to get, for example, the x-intercept, we know that our y is equal to 0, or we are solving the equation f of x, g of x equals to 0. For us to get the y-intercept, we know that we let our x to be equal to 0, and we evaluate our f of 0, g of 0, k of 0, depending on how the function is given. We should also look at the equations of the axis of symmetry. We know that there are functions that have an axis of symmetry, and there are some functions which do not have the axis of symmetry. We will look at these as we move along. We should know functions that have an asymptote and how we represent our asymptote, and how the asymptote is represented if we are given a sketch of a function as well. We should also focus on the turning points. We know that some functions have turning points, some do not have. We should also look at the concavity of our function, which focuses mostly on the shape of our function, and we shall be discussing increasing, decreasing functions and how we can help in understanding the concept of concavity, and when we are supposed to sketch a function, how you come up with the correct shape. If you are given a shape, how do you correctly interpret that particular function? Now, we should also look at the different notations for representing our domain and range. We are aware that mostly we should understand the terms domain, which is the x values where our function is defined, and our range, it's our y values where our function is defined. But there is a correct way of representing the notation for our domain and range. Our inequalities, I know we have got a greater than sign. It always opens up to the bigger one, and it always points to the smaller value. So we must understand that the first sign that we are having there, reading it from left to right, it's a greater than sign, but you can read it from right to left, it becomes a less than sign. So we have to be flexible and know how we use the inequality signs. Now, we should also understand the basic graphs and identify the type by looking at the form of the equation or the shape of the graph. If we are given a sketch, we should be able to do that. And we should also be able to analyze the information given for the function to help us answer the questions accordingly. And as learners, we must have a clear understanding of the question, which is very important before we answer any question. Now, we shall look at questions that involve inequalities. For example, we have f of x greater than 0, f of x times g of x. Please do not multiply functions because those questions normally are 2 or 3 marks maximum, where you are supposed to just use your interpretation of the meaning. Greater than, you know that it means above, less than, below. If it's greater than 0, it means it's on the positive side of your x-axis, or it's on the positive side of your y values. If it's less than, it means it's on the negative side of our y values. Now, we shall look at the characteristics of our functions. I will start by looking at the linear function. The linear function has two forms of the equation. You can use y is equal to mx plus c, which you normally use again in paper 2, as well as f of x is equal to ax squared plus q. That one, we should know what the parameters are representing. In this case, our m or our a represents our gradient. For example, if you are given y is equal to 2x plus 6, it means your a is 2. And what does that 2 represent? In this case, 2 is positive. It means our function will have a positive gradient. So when we are sketching, in most cases, we are supposed to just have our x and y intercept. We use the dual intercept method. Once we get our x-intercept and our y-intercept, we should be able to sketch our graph because the shape is determined by the value of m or the value of a. In this case, it will be our a is 2. It means our graph will be an increasing function. It will have a positive gradient. We'll get our x-intercept by substituting our y as 0, then we solve for x. In this case, we are going to get our x as negative 3, meaning our x-intercept will be negative 3 and 0. And our y-intercept, as you can see there, you are able to see that to get our y-intercept, it is, you substitute x as 0 there, and we'll get our y-intercept as 0 and 6. And we are able to quickly do the sketch of the function. Negative 3 will be somewhere there, and our 6 is on the positive side of our y values. From there, the gradient is positive, you just join, and then you have your straight line function. Now the domain, x is an element of real numbers, meaning it's from negative infinity to positive infinity. Our y, it's an element of real numbers. Again, our graph, it's defined for all y values, hence the range it's given as that. It has no turning point, it has no axis of symmetry, and it has no asymptote. That's our linear function. We move on to the next one. The parabola. Parabola is also known as a quadratic function, and we are able to see the three kinds of our equations or forms of the equation of the parabola. The first one, we know it's the quadratic form. Normally, when you are given this form, you will be expected maybe to find the turning point, to find the x-intercepts, and then you are supposed to look at the shifts that can occur on that particular function. And we are able to solve any question that requires the solution for it. And then we have got the second form. So the first one, we are calling it the quadratic. The second form, this one, we call it the turning point form, where you are given a as it's factored outside. Then we have x plus p squared plus q. I know the method of completing the square, and we do not like it from grade 11, but we should just practice it as it helps to make our life easy. This one, in most cases, you'll be given the equation or a sketch with a turning point and any other point, and in most cases, you are supposed to come up with the equation, or you'll be expected to move from the quadratic form and you go to the turning point form. I'll call it the TP, turning point form. And from that one, you are able to deduce the information. You are able to extract information about the shape, because our A determines the shape. Our turning point is given by negative P and Q, and we have to be careful about this one. Some sources use A x minus P squared plus Q, but according to the curriculum, we are supposed to use the form that is given there. It must have a plus. So if you are given the first form, it means the coordinates of the turning point will be PQ. But if you are given the standard form that you are expected to use, the coordinates of the turning point must be negative P and Q. And then the third form, which we shall call the intercept form. Normally, this one is given as a story where you are told the x-intercepts are given as this, and then point P lies on the graph as that. So they can give you a sketch with the x-intercept and any other point, or they can give you a story about the x-intercepts and a point. Then in most cases for this one, you'll be expected to show the equation in the given form that they would have given you. And we are expected to substitute the x-intercepts as our x1 and x2, and then we determine the value of A. Once we get the value of A, then we substitute back into the formula, then we get what we are expected to get. Now, A determines the shape, as you can see. If our A is greater than 0, meaning our A is positive, our graph is concave up. I always like putting the axis of symmetry there, because I know that if I'm able to get the equation of the axis of symmetry, I'm able to get the coordinates of the turning point, and that makes my life easy in determining the range or the maximum value or the minimum value, depending on whether my function is concave up or concave down. As you can see, if our A is positive, we'll have a concave up function, and we know that up to the axis of symmetry, our function decreases. We have the turning point, then it increases again, because these are the kind of questions that are asked: for which values of x is our function increasing or decreasing? We should be able to interpret those questions based on the shape of the function that we are working with. Our A less than 0, our function will have a maximum turning point, and we know that it's concave down, it will increase up to the turning point, then it decreases. And we know that the turning point is always at the axis of symmetry. It divides the graph into two equal halves, and it's an important fact that we must always remember when we are dealing with our quadratic function or parabola. Our domain, if it's not restricted, x is an element of real numbers from negative infinity to positive infinity. To get the range, we must get our x value at the turning point, and we use the equation of the axis of symmetry, and we are able to get that at the bottom of the slide there. You are able to see we can use negative b over 2a, or we can use, if we are given the x-intercept, it's x1 plus x2 over 2. That will give us the x value. We take the x value at the turning point, or our equation of axis of symmetry, we substitute it to our original function, then it gives us the corresponding y value. Or if we are given the turning point form, we can just extract our p as x is equal to negative p there, because we are using the posit x plus p. We just take whatever is inside the squared bracket there. It helps you to get your x value at the turning point, or the equation of the axis of symmetry. From there on, we substitute back and we get the corresponding y value at the turning point, and that helps us to get our range. In this case, our range, it's always given by whatever we have. You can see that if our graph is concave up, it will have a minimum turning point, and our range will be given by y is greater than or equal to q, or using the notation, our y will be an element from q to positive infinity. We don't know where infinity ends, so we will have that. For the second one, if our graph is concave up, it will always have a minimum, and if it has it's a maximum. So in this case, we will always have our range as y. It's an element from negative infinity to positive q, or whatever value of q that we are having there. Because our graph is concave down, it will have a maximum turning point. Whatever we have as the y value at the turning point becomes our maximum. Then I've talked about the turning point, how we determine it. We can also use calculus to determine the coordinates of the turning point. Remember, we can find the first derivative of our function. We know that at the turning point, the gradient is 0. We equate to 0, then we solve for x at the turning point. Then we substitute into the original function to get our y value at the turning point. Moving right along, I'll talk about a hyperbola. The hyperbola takes the form f of x is equal to a over x plus p plus q. That is the standard form. But it can also be given in this form, which will require us to use our factorization to move this form to that form, and we should be flexible to move in between the given forms. Then there is another one that our examiners like. They can give us the equation in the form y minus q times x plus p is equal to a. Something like that. So we will have to rearrange this so that it comes there. So we should be flexible among the 1, 2, 3 forms of us being given the equation of a hyperbola, and we are able to work with it. Now, if you check, For a linear function, a or m, we said it represents the gradient. For our parabola, our a represents the shape. And the way we are getting the a in the given functions is different. So we have to be careful. The a for a linear function, we use gradient formula to get a. Our a for the quadratic equation, we know that we can use the x-intercepts and a point, and that will give us a. We can't use the gradient formula for us to get a for a quadratic function. Same as for our hyperbola. Please, we need to understand what the parameter represents so that we do not lose marks. Those are common mistakes that we have seen before. Question says determine the value of a, because for a linear function we use gradient. The person sees 2 points and just calculates gradient, and it's a wrong way of doing it. So we have to be careful. Let's deal with each function. That is why even now I'm explaining the importance of the parameters for each of the given functions so that we are able to answer the questions correctly and accordingly, and we do not unnecessarily lose marks. We'll move on. Now, our a for a hyperbola also represents the shape, and we are able to see that if our a is positive, our hyperbola has asymptotes where our function is not defined, and we are able to see that if our a is positive, we have a decreasing function, and this function also has equation of axis of symmetry, and it's 2 of them. So the importance, the quadrants are formed by the asymptotes. If our a is positive, our function is in quadrant 1 and 3. 1 and 3. If our a is negative, our function is in quadrant 2 and 4. So you should always know that your hyperbola must have 2 arms in the given quadrants. You cannot have them looking like they are flying away from each other. It's always quadrant 1 and 3, quadrant 2 and 4 as a way of determining the correct shape, especially if we are supposed to sketch, and our a determines the position of our arms there. Domain, we know that our function is not defined on the asymptote. Hence, when we are writing the equation of our domain, x is an element of real numbers, we exclude the equation of the asymptote. Y is an element of real numbers, we exclude the equation of the horizontal asymptote. And please be careful here. When the question asks you to give the equation of the asymptotes, please avoid using P equals, Q equals, because those are common mistakes that we make. Our equations must always be x equals, y equals for the asymptotes. The function has no turning point, but it has our vertical asymptote. I have given you, it's x equals P, y equals q. Yes, the question might ask you to solve what is the value of p, but p is not, you cannot say p equals is an asymptote. It has to be x equals that value of p that you calculated for you to get your vertical asymptote and horizontal asymptote. And then we have got the equations of the axis of symmetry. For you to get the equations, either you use the point of intersection of our asymptotes. We know that each one, the one with a positive gradient, the gradient is always 1. And the one with a negative gradient, the gradient is always -1. And they both pass through the point of intersection of our asymptotes. So we can use that point to get our equation in the form y is equal to mx plus c. we just substitute the gradient as +1 or as -1, depending on the question. Sometimes examiners trick us. They will ask us to give, they can name and say the equation of the axis of symmetry that has a positive gradient. We know the one that has a positive gradient, it's an increasing one. We know the shape, it must move from negative to positive side. And then sometimes they ask us the equation of the axis of symmetry that intersects the function, in which case for a decreasing function, it will have a positive gradient. For a decreasing function, it will have a negative gradient. So we have to be careful of the technicalities there of how the question is asked, and we do it accordingly. Then we have an exponential function. It takes the form a times b to the power x plus q plus p plus q. Now, exponents, we did them from grade 8, but up to now, some of us, they do not know the meaning of an exponent. We make mistakes when we are dealing with exponents. You cannot multiply a by b, then raise it to the power x plus p. A, you take it as a coefficient. B to the power x plus q, you take it as one term. You cannot now say a times b, then you raise it to the power x. This cannot multiply. A is a coefficient, b is the base, x plus p is the exponent. So for you to get exponential form, that term must have a base and a power or exponents, and then a is a coefficient. It cannot multiply the base and then you have one base there. We have to be careful. And our exponential function has a horizontal asymptote. We can see that part. And we know that our base can be any number greater than 1. And we know that we will always have an increasing function. If our base is a fraction between 0 and 1, we know that we have a decreasing function. Still, it will have an asymptote there. And then if our b is greater than 1 and a less than 0, in this case, a determines the shape, as you can see. If a is positive, it's an increasing function. If a is negative, you reflect about the asymptote. You will see as we do questions along. And we know that the range, it's either our function is defined above the asymptote or below, depending on the equation. So we should give the range as such. As you can see, for this one, we cannot use equal to for reasons that it's an asymptote. Our graph should never touch or intersect the asymptote. It has no turning point. We can only stretch or the arm of the exponential function, but we cannot have a turning point. It turns, but it's not a turning point. It's just following the shape according to the exponents that we are using. We do not have a vertical asymptote. We only have a horizontal asymptote. We do not have an axis of symmetry. That's our exponential function. Now, I would want us to start looking at questions, and the tips are always read the question and understand first. The story that is given above a question is very important, even if it's followed by a diagram. Please read, because there is some information that you can extract from the story and you add it to your diagram, making your life easier. We analyze the information, we analyze the diagram to see what can help us answer the given questions. We can use colors to highlight what we can see, as well as making our life easier. Like you saw, I added the equation of the axis of symmetry. I added the information where I can say my function increases, then turns, and then decreases. It's a way of helping me interpret the information that I'm given in the diagram. Implied information, if you are told that it's a turning point, it's implied that's your minimum or that's your maximum point. Your graph is not defined either below or above that point. If it's a maximum turning point, your graph cannot. So from there, you are able to deduce your range. You are able to also deduce the coordinates of the turning point. We should be able to read that. Now, once we have read, understood, and then broken down the information, you are eliminating some stuff that is not helping you to answer that particular question. You can now brainstorm and develop a rough solution. You link the information that you are given and then that you have acquired, as well as you now rewrite the formal solution. You answer your question, you move to the next one. Now, please be careful. You cannot use information that is shown in question maybe 6.2 to answer 6.1. You always have to answer questions sequentially. And if you are given a diagram, you should be able to add information to your diagram to make your life easy to answer the next question. I would ask us to answer that question 6, but I'm going to break it down into 2 parts so that we do not take too long answering the question. I'll give you 7 minutes. You answer question 6.1, 6.2, and 6.3. After 7 minutes, we will discuss the solution. Then I'll give you more time to answer the rest of the questions. Please note, read and understand the information, add information to your diagram, and try by all means to understand the question and what it requires before you start writing down your solution. Okay, we will discuss the solution of 6.1, 6.2, and 6.3 after 7 minutes. Let's attempt answering the question there. Welcome back. I hope we have managed to do the solutions for 6.1, 6.2, and 6.3. Let's try and mark ourselves. Now, there is our 6.1, it's 2 marks. Sure, so the key word there is sure. And you are given the equation. So our steps must help us. We know that it's a linear function. Our g of x is equal to mx plus c, or our g of x is equal to ax plus q. This is the form of a linear function that we are going to look at. Now, it's a linear function and it has those two forms of the equation. So our job is to find the value, to show that the value of m is 1 and the value of c is also 1. This has to come from us. We cannot just say m is 1, c is 1 without showing how we are getting that m is 1. That's what the question is asking us. So I'll add our y-intercept is there. We know that the coordinates of this point are 0 and 1. We are just given 1 there. And it's a straight line. And I know for me to get the gradient of a line, I must have 2 points. So to answer 6.1, I will then now say the gradient of the function g will be given by m is equal to, using the gradient formula, y at c is 5 minus y on our y-intercept, which is 1 over 4 minus the x value there, and this will give my gradient as 1. Also, we explained on the first slide for our linear function that whatever we have as our y-intercept becomes our c or our q. So already, to get the value of c, our c is equal to 1 from the y-intercept, which is 0 and 1. Therefore, we are able to get our equation g of x is equal to mx plus c. We put, in place of m, we put our 1. In place of c, we put our 1, and we'll have our equation as such. So the mark, will get it for the gradient as well as for the value of c, in which case our c is equal to 1, like that. Then we are done. We get our 2 marks. Now, we move on to the next question, 6.2. Right, that's how we get our gradient. M as 1, we get our mark, and c as 1, we get our mark. Now, or alternatively, we substitute the coordinates of point C into the equation, and we show that our gradient is 1. That's how we are showing. We are not just writing down the equation. Now, calculate the coordinates of A and B. If you check, A and B are our x-intercepts. So, that's how you are looking at it. A and B, those are your x-intercepts. How do you get your x-intercepts? We know that our f of x is equal to 0. So where there's f of x, you substitute, and you will get x squared minus 2x minus 3 is equal to 0. You solve. This can be easily factorized. The factors are x minus 3. The middle term is negative. The bigger of the two factors. For you to get negative 3, you multiply 3 by 1, and it will give us that. So we'll get our x as 3, or our x as negative 1. But we know that A is on the negative side, so A must have the coordinates negative 1 and 0, or B will have 3 and 0 as our code. The question is specific coordinates. It didn't just say calculate the x-intercepts. It's the coordinates. So your final answer must be in coordinate form for this case. We move on to 6.3. So we move on to 6.3. Determine the range of f. Now, the range of f requires us to get some more information that we do not have. So in this case, I know that somewhere here I've got my equation of axis of symmetry. I must get the coordinates of the turning point. Here I have -1 and 0. Here I have 3 and 0. Here I have 0 and 1. You are adding information to your diagram so that it makes your life easy. Now, how do I get the coordinates of the turning point? Because once I get the coordinates of the turning point, I'll have the y value at the turning point, which will give me the minimum value there. So the easiest way I can use for me to get the equation of the axis of symmetry, I can use -b over 2a, and I'll substitute my b is -2 over 2, my a is 1, and that will give my x as -b, so it's negative of -2 over 2 times 1, and that will give us +1. Once I get my equation of the axis of symmetry, it gives me the x value at the turning point. And I know that I said f of -b over 2a, the coordinates at the turning point are -b over 2a and f of -b over 2a. So my x is 1. I evaluate f of 1. Where there's x, I'll substitute 1. I'll get 1 squared minus 2 times 1 minus 3. And I'll get my f of 1 as 1 minus 2 gives us -1 minus 3, that gives us -4, meaning the coordinates of the turning point are 1 and -4. And we said whatever we have as q at the turning point, we know that our graph is concave up, so it means this is the minimum point, so our y must be greater than or equal to -4, or y is an element from -4 to +infinity. The brackets have to be correct there for our range. So we'll get a mark for obtaining the coordinates of the turning point, and for the correct notation, get our x, get our y value, then the correct notation for our range. We get our 3 marks there. Now, put this information to your diagram. It will also help you to answer the following questions. We move on now to 6.4. I will take you back a little bit so that you are able to answer the other questions. Let's quickly go back. Now you will answer Now you will answer 6.4 up to 6.6. I'm going to give you 8 minutes to answer 6.4 up to 6.6. 8 minutes, you answer 6.4 up to 6.6. Welcome back. I hope we have managed to answer question 6.4 up to 6.5 and 6.6. Now I will move on so that we quickly answer those and we move on to the other types of functions. Okay. (6.41) If mn is equal to 6, determine the length of OT if t lies on the negative x-axis. Show all working. It's 4 marks. Now, if you check, m it's on the function f of x and n it's on the straight line. So this means it's implied information. We must get the length of mn in terms of our functions, and we know that mn will be given by f of x minus g of x. It's always the upper function minus the lower function. So we know that mn will be given by our f of x is x squared minus 2x minus 3 minus our g of x is x plus 1. And we know that our mn is 6, and then x squared, negative 2x minus x will give us negative 3x, negative 3 minus plus 1, that will give us negative 4, meaning we will get x squared minus 3x minus 10 is equal to 0. We are already solving a quadratic equation. If factorization is a challenge, you can use the quadratic formula, but this can be easily factorizable. This will give us x plus 2, x minus 5, giving us 0, and we'll get our x as negative 2 or our x as positive 5. You are able to see that for that point t, our x cannot be positive, hence this is not applicable, but we haven't answered the question. The question is calculate the length of OT. So the x value at point t is negative 2. Remember, for us to get OT, we know that it will be the x value on the right, giving us 0 minus negative 2, and that will give us our answer as 2 units. It says calculate the length of OT, we get our 2 units. For equating, for subtracting and equating to 0, standard form, x values, the length, and we should reject the x is negative, it's positive 5, or the 5 units as the length, because we are dealing with the distance on the negative x values there. The term hence, it's always a connecting word. Hence, from what we have done above, we should be able to answer the next question. We said the x value at t, it's negative 2, meaning the coordinates here are negative 2 and 0. So it means the coordinates here at n, it should be negative 2 and something. And in this case, we must get that value there, which comes with, let me put a y value, negative 2 and y. So to get that one, we already found the function g of x for the straight line. So there we said our g of x, it's x plus 1. G, our x value there, we are saying it's negative 2, which means it's negative 2 plus 1, giving us negative 1. So the coordinates at point n will be negative 2 and negative 1. We get our 2 marks for substitution, and for the answer there, we must get the 2 marks there. So we have done the 6 marks very fast and we are getting them right. We move on to 6.5. We know that a tangent, it's a line that touches a curve at only one point. So we know that this red line, it's parallel to the function g of x. What is the common characteristics for parallel lines? They are equal distance apart. We all know that. They will never intersect. And from calculus, we know that, or from analytical geometry, we know that parallel lines have equal gradients. So the common feature there is gradient. But how do we now connect the two? Because they're not intersecting. In this case, we cannot equate f of x to g of x or something because they are not intersecting. They are parallel to each other. So we know that our f of x is given by x squared minus 2x minus 3. We integrate the topics. If we are talking about gradient, we know that it's the first derivative, which will give us 2x minus 2. Now, from there on, we know that the gradient of g of x, we calculated it, we found it as 1. So it means our gradient is 1. The first derivative gives us the gradient function. Our gradient is 1, 2x minus 2. And that should give our 2x as equal to positive 3. And we get our x as 3 over 2. This is the x value at the point of contact between the function f of x and the tangent. So that will give us 3 over 2. We must get the corresponding y value there. So to get the corresponding y value, we evaluate f of 3 over 2, which should be given by 3 over 2 squared minus 2 times 3 over 2 minus 3. Using your calculators, that should give you negative 15 over 4. So it means the point of contact between our tangent and the parabola, the coordinates are 3 over 2 and negative 15 over 4. But we want the equation. So we know that this is a straight line. It should take the form y is equal to mx plus c. Our m, it's 1 plus c. Then we substitute the coordinates at the point of contact, 3 over 2 and negative 15 over 4. Then we are going to substitute negative 15 over 4 is equal to 3 over 2 plus c. And we should get our c as negative 21 over 4. And the equation of our tangent will be given by x minus 21 over 4. We get the equation of the tangent. Doing the derivative, we equate it to 1. We get the x value. We get the y value, the coordinates at the point of contact. We substitute the points into the equation. Then we get our equation. We get our 5 marks there. And then for which values of k will f of x equal to that and h of x, which is the tangent, not intersect. Now, remember, any line which is parallel to g of x or h of x will intersect the graph. So the tangent is only intersecting once, but these other ones are always intersecting our function f of x twice, because it has to have the other at the lower point and on the upper point, because they are parallel lines. So we have so many parallel lines that are intersecting this curve. In this case, we want to make sure that this tangent here does not intersect the graph, but it's still parallel, but it does not intersect. In this case, our y-intercept here, we found it as 0 and negative 21 over 4. So it means our k in this case must be less than negative 21 over 4, because once it's less than that, it means it does not intersect the curve of our parabola. Hence, our solution to this question will be k is less than negative 21 over 4. We are using the solution that we got here to help us answer the next question, but we must understand the meaning of this intersection. They do not touch, they do not intersect. We move on now to activity 2. Activity 2 is fairly straightforward. I'll give you 6 minutes to answer activity 2. 6 minutes. Let's quickly answer activity 2. It's on a hyperbola. Welcome back. I know this one was a fairly straightforward question, and we are going to quickly mark it, and then we move on to our exponential function. Now, given f of x is that, we know that for us to have the general form of our hyperbola, x plus p plus q, this is the standard form. Write down the domain. You are able to see that x plus p equals to 0, so you are going to take x minus 1 equals 0, because that makes this fraction to be undefined. Our x is equal to 1, meaning our function is defined by all x element of real numbers, but our x cannot be equal to 1. We get, write down the domain. That's our domain. You get a mark. Write down the asymptotes of f, the equations of the asymptotes. I've already given you one. X is equal to 1. This is our vertical asymptote. If you check there, the value of q in this case is 0, meaning our y equal to 0 is our horizontal asymptote. Question 5.3. Sketch the graph of f, clearly showing all intercepts with the x's and any asymptotes. So for our asymptotes, we got our 2 marks there. Then sketching the graph, we know we need our x-intercepts. In this case, we will not have an x-intercept because our y equals to 0 is our asymptote, meaning our x-axis is our asymptote. So you start no x-intercept. For us to get the y-intercept, we know that our x must be 0, negative 1 over 0 minus 1, and that will give us 1. So our y-intercept is 0 and 1. Now, we also are able to see that in this case, our a is negative, meaning we have our asymptotes, and the arms of the graph must be in which quadrants? Remember, if a is negative, it's quadrant 2 and quadrant 4. So we have the shape of the graph. Now we can quickly do the sketch, and our sketch would look like that. Remember, we said our x-axis is an asymptote. Our graph will never cross that. So I'll encourage you, always give the coordinates of the point of intersection of our asymptotes. It's 1 and 0. Then the arms, that one, we got it, it's 0 and 1, we are aware. So you'll get a mark for your vertical and horizontal asymptote, your y-intercept, and for the shape, you get your 3 marks. For which values of x will x times f dash of x be greater than or equal to 0? This is an interpretation question. If you look at it, below the x, on the before our y-axis, we know that our x values are negative. Above, we know that our x values are positive. Now, the challenge is getting that part, because you are not going to multiply x times the first derivative of that. So this requires us to have an understanding that this question is just testing us in knowing that if I have f of x in the form negative 1 over x, because the derivative of this, we know that this is negative x to the power negative 1, which before we do the derivative, f of x will be equal to negative x to the power x negative 1. This will give us a positive x negative 2, which is the same as, it's a positive, which is the same as saying 1 over x squared. So this is f dash of x. And we know that for all x values, 1 over x squared will always be positive. But in this case, it means our f dash, the derivative of this, is positive there. So we are looking at having this will be positive, the derivative will also be positive. You are multiplying a positive and a positive, the answer will always be positive. So in which case, our solution will be x is an element of real numbers, but our x has to be greater than 0, and our x cannot be equal to 1 because x equals to 1 is our vertical asymptote. Our graph is not defined there. So to make our life easy, we can just say x is greater than 0 and x not equal to 1, or we can say 0 in this case. Because of the equality sign that we have, our x can be greater than or equal to 0, but it cannot be equal to 1. So using the other notation, we can say our x the first part, it's between 0 and 1, or our x is greater than 1. So that will be these different kinds of solutions that you can give to that question. We will move on now to the next question, which is our exponential function. I will give you 5 minutes to answer that one. 5 minutes. Let's answer activity 3. 5 minutes. Welcome back. This is our exponential function. Now, remember the parameters. When we're explaining the characteristics, we said A represents shape, but in this case, you can see that A is used as a base, so we must interpret the question as per situation. We should not fix our mind to saying A only represents this. Now, we are given the coordinates of a point, and we should write down the coordinates of t. If you check t, it's your y-intercept, and we know that to get the y-intercept, our x is 0, so we must get g of 0 there. And g of 0 will give us a to the power 0, giving us 1. So the coordinates of t are 0 and 1. You get your 2 marks. The value of a, we are going to substitute the coordinates of point S to help us get the value of a. And we'll get 9 is equal to a squared. From our laws of exponents, we know that 3 squared is equal to a squared. Bases are the same. Exponents are the same. We equate the bases. Our a is 3. You get your 2 marks there. The graph of h is obtained by reflecting g in the y-axis. Write down the equation of h. We know that if we are reflecting about the y-axis, you know what happens. So our y-axis is this, so it means we are reflecting. This point comes that side, and that point, the graph will be like that if we are reflecting about the y-axis. And we know that if we are reflecting about the y-axis, we know that h of x is equal to g of negative x. So we know that the equation is given by of g of x, it means it will be 3 to the power negative x. That's our h of x. Using laws of exponents, you can write it in different versions, and we are able to get our equation as y is equal to that one. So our answer will be that, or it will be that. We get our 2 marks. Write down the values of x for which 0 is less than the logarithm to base 3 of x less than 1. Now, we know that if our g is an increasing function, the inverse will also be an increasing function. It's a reflection about the line y is equal to x. We know that at this point, we have coordinates 0 and 1. And somewhere here, we have coordinates. When our x is 1, our y will be 3. Something like that. And on the inverse, we know that these interchange will have 1 and 0. And somewhere here, we'll have 3 and 1. And the inverse of an exponential function, our f of x is equal to 3 to the power x. The inverse will be the logarithm to base 3 of x. That's our f inverse. Now, our solution will be given as follows. G of x is increasing, so where there is our base is 3 to the power 0, we take the values there, and that will give us an answer of 1. Our x value here and our x value there, it has to be between 1 and 3. Hence, our solution will be given as such. Now, I wanted us to talk about the inverse functions, though time is no longer on our side, but I will talk about, for our purposes, we must know how to get the inverse of a straight line function, a quadratic function in the form ax squared only, and we should also know how to get the inverse of our function y is equal to exponential function y is equal to b to the power x, our b greater than 0 and b not equal to 1. And then we know that a function purely defined, it's when you have, for every x value in our domain, it must be associated with only one y value on the range side. And we can picture that one where we say this is our domain and our range x1, x2, x3. On our range, we should have y1, y2, y3. And we know that for a function to have an inverse, it has to be 1-to-1, meaning for every x value, there must be only one y value associated to it on the range side. And the inverse of a 1-to-1 function is also a function. And we know that for a function to have an inverse, which is also a function, it has to pass both the vertical line test and the horizontal line test for it to be a one-on-one function. And also, we know that when we are dealing with inverse functions, whatever is the domain on the original function becomes the range on the inverse function. And whatever is on the range for the original function becomes the domain of the inverse function. And we are encouraged as candidates to always write the domain and the range of the inverse function so that we are able to get things right there, especially for the inverse of the quadratic one. For a linear function, we also must have a restricted domain. And the steps of obtaining an inverse function, we just write the equation in the form y equals. I have given an illustration there of how we get the inverse of a linear function, quadratic function, as well as exponential function. You can take a picture of that because time is no longer on our side. I will move on now to the next part of sketching the inverse function. We know that we must draw the graph of the given function first. We draw the line of reflection. It makes it easier when you are doing them on the same set of axes so that you get the shapes right. You must have at least 2 points so that you are able to just swap the coordinates. Whatever is our x-intercept becomes our y-intercept. Whatever was our y-intercept becomes, you just interchange x and y values. Then here is an illustration of how the shapes would look like for sketching inverse functions. You can take a photo of those ones. For exponentials, we have only 2. For the linear, we also have 2. If it's an increasing function, the inverse will also be increasing. If it's a decreasing function, the inverse will also be decreasing. For the quadratic, that is where we need to restrict our domain. But because time is no longer on our side, I will not be able to explain more on that. But in our future lessons, we will deal with this aspect. Now, here is the question for activity 4. I will ask you to take a picture of it and you attempt it when you get home. There, I will pass. There, it's another activity 5 where we are supposed to look at the inverse function problem. I will pass that one. You can take a picture. Then the solution. For homework, I had planned that we do a different form of an inverse of our hyperbolic function so that we try and see the different versions of how some of these questions can be asked in an exam. I will pass those. And then for homework 2, it was an inverse function. It's an inverse function. We will deal with it next time. So, in summary, we have looked at the importance of analysis. whenever you are given a question, analyze the information that is given. You link information with the type of function that you are working with. We are encouraged to indicate on the diagram what we can see from the given information, and we write down the solution from there. We are discouraged from just writing everything that is not relevant for the particular question. We understand the question before we write the solution. It will help us a lot. I indicated this one. We cannot use a follow-up question to answer the previous one. And just writing correct but irrelevant statements will not help us get any marks in an examination. Emphasis is always on the importance of the correct order when showing the determination, for example, of an equation of a function. You cannot start from the end and just say a is equal to 3 before showing how you arrived at that 3. Those steps are important. We should not start with what has to be shown. I indicated this one when we were doing the question where we're supposed to show the equation of g of x as an example. We are supposed to show how we get the gradient, how we get the y-intercept before we can just say the equation is like that. The use of color is encouraged to help you see. For example, if it says f of x is greater than 0, you can highlight that part of the function which is above the x-axis. And it is important that we refrain from making assumptions, as assumptions will not award us marks in the exam. And I wish you all the best as we prepare for the exam. It's closer. Let us keep on practicing, and we use all the resources that are available at our disposal. We concentrate on what we are doing. We use our teachers and all the other available platforms that can help us do well in these examinations. We will see you next time. Thank you. Have a good afternoon.